What's going on, YouTube? So today we have a service call for an ice machine in a dining room that isn't making ice. To give you a little bit of context on this service call, because it makes me antsy inside. I'm very excited for this service call because it is a brand new ice machine that was installed by somebody else. Now, this location contacted me and requested a quote to install a new customer supplied ice machine. A manitowoc, I think it's a quiet cube, remote condenser, line set, the whole 9 yards, right? So I came out here, looked at what they had existing on the property, gave them a bid, what I thought was fair. I did add a little bit of extra time because there were some variables that I wanted to account for that I didn't know how we're going to play out, essentially. Like they had some old equipment that was existing on the roof that I figured, well, since I'm already here moving condensers around, I have a crane, I'm going to get all this there's 2 extra condensers up on the roof. One for the existing ice machine they wanted replaced, and then one that had been abandoned sitting next to that one. I'm like, well, I might as well get rid of those as well, right? So that's what I plan on doing. And then along with that, I had to update the disconnect. The electrical whip going down through the building needed to be upgraded because it was, sun damaged and cracked and split. Just a lot of little things that if we're going to be doing a full changeover, I'm going to address all these issues at once, right? And they got back to me and they're like, why is this so expensive? And I explained everything. I had it all documented in pictures. We need a new disconnect, a new whip. Your communication cable that goes from the condensing unit to the head of the machine should be in some sort of seal-tight whip. New penetrations through the roof, yada, yada, yada. The line set's going to take some work coming down through the wall. I mean, there's a lot of man hours in the demo process, the install process. And it was just this whole big thing, right? Now, hold on, guys. I got the one and only Chris Stevens from HVACR Videos calling me. All right, hold on. Let me take this call here, guys. Hey, what's up, Chris? Oh, no, man, you're good. I'm just filming a video. What are you doing? Yeah, no, I saw your video. The last one you put out. Yeah, I saw it yesterday. Yeah, it's pretty good. I mean, I liked it. Yeah, I know. You still have more subscribers than me. I know. How many? I don't know how many more you have than me. I didn't count. Oh, yeah, that's a lot more than me. Yeah, I know. You still beat me. I get it. No, I mean, yeah, you're doing great. I mean, you're crushing it. I mean, don't get me wrong. Yeah, I know. You got the fancy YouTube thing on the wall. I know. Do I know how many subscribers you have altogether? I don't know. No, I don't. I didn't keep track of that. No, I'm sorry. I guess I let you down. All right, man. Well, I'm gonna get back to filming a video here. So yeah, if you want to just call Adam and Joe and talk to them, I guess. All right. I'll see you later. This wasn't awkward at all. All right, bye, buddy. Love you. That guy, he's a wild character. Anyway, guys, enough screwing around. Let's go check out this ice machine, and I'll try to show you as much as I can without getting in the way of management or customers or anything like that. All right, let's roll, guys. All right, here's our ice machine. Currently, it's running water across the evap, making ice. Line set looks amazing. So T1, 2, 3, and 4 are all the same temperature. They've been freezing for 29 minutes. We don't have any compressor action going on here. checking our liquid solenoid right there. It is energized, magnetized, vibrating, feels open. I'm gonna go get my gauges. I'll slap our gauges onto here and see what the deal is. Alright, right now we're in harvest because we exceeded the maximum freeze time. We're running. We have gas, but we have no compression. I'm surprised we even have gas. I was under the assumption we didn't have any gas. I did check the valves back there appear to be open all the way, so I'm gonna jump up on the roof and see what's going on up there. Alright guys, we're up on the roof. First thing I found, slightly used vape pen. I'll be stealing that later. See, spray foam, that's a good sign. There's one condenser over there. That's for our drive-through ice machine. I don't care about that one. And here's our condensers. So this is the new condenser that was just installed. This is an older abandoned condenser. They removed the second drink station from this location, I don't know, maybe a year ago, and they just abandoned the condenser up on the roof. So again, like, part of my quote was to, since I had to lift this one up with a crane, I was going to remove this condenser, get it off the roof, along with the old one, which is the old one is over there. I don't know why they didn't remove that, but now it's just sitting here on the roof because, you know, just because. Let's see here. We obviously have no compressor action going. Check out this roof penetration. Also, part of my quote was to do a proper roof penetration. This is just spray foam, obviously. Spray foam with what appears to be Flex Seal over top of it, right? And then on top of that, it doesn't look like... So when they spray foamed this in, they didn't cut the insulation around the pipe on either one of these lines. So, I mean, what's going on is the spray foam is only touching the insulation, which is fine for now, but over time, as this insulation breaks down, shrinks, dry rots, all that fun stuff, it's going to leave a gap right here and a gap right there, which is obviously going to let in tons and tons of rainwater. And I mean, it's just not the proper application. But again, you know, this is what you get. Lobby ice. What do we got going on in here? So they did put a new disconnect on. Well, that's surprising. Huh. They even have a new whip in there. That's good. That's good. But why do we have nothing going on? Let's see. Was this thing even in the on position? Let's put it back in here. See. Yeah, that was on. So we'll start off by checking our fuses, actually verifying we even have power up here, because I got no noises, no nothing going on. All right. All right, so our fuses are good. Let's see if we have any voltages. I don't know how well you guys can see that, but I do have 210 volts. So let's plug our disconnect back in, and then we will move around to this control section here. Alright guys, I'm going to think out loud here for a little bit. I was under the impression when I quoted this that there is supposed to be a communicating line that goes from the head of the ice machine to the condenser, but I don't see the normal little terminal block that I'm used to seeing in some of these models, so I gotta check to see what actually tells this condenser to turn on. Could just be simple, you know, pressure switches, kind of like a classic pump down system. But all that, I did verify that we do have incoming power at the bottom of our contactor. But if you'll notice, I don't know how well you guys can see this, but I don't know how well it's coming across on camera, but this contactor is just, it's not pitted, but it's already heavily charred. Like there's a lot of just black carbon buildup around this contactor. I mean the one side that opens and closes, of course. Which, if I had to guess, is probably from excessive opening and closing. Again, not real sure what would cause that, because I'm also not real sure what even controls this condenser yet. So let me figure that out first. Check condenser fan motor, blah blah blah, see voltage, make she single phase. Yeah, 208, 230. All right, that's fine. Interesting. All right, let me dive into this a little bit more, and I'll bring you guys back around in just a second. I know the lighting's not the best, so what it appears to be is our compressor contactor is energized through this timer block right here. We have one side of the contactor coil continuously powered through red L2, right? Following me so far? One side of the contactor coil, the other side, which is our yellow, right there, goes up through here, and it goes right there. And I'm assuming this is between 1 and 2 is a normally open circuit, and then it's closed. But what tells it to close, I wonder? So I assume they're using blue as a common. Yeah, so L1, L2 goes through high pressure cutout, low pressure cutout. I'll have to check those as well. I didn't check those yet. I just went straight to my contactor coil so far. I don't have the 208 volts sitting at my contactor coil. I also checked across 1 and 2. That is open right now. So next up we'll check our high pressure and low pressure cutouts. Alright, so if you'll notice right there, our blue wire going into the terminal number 2 on the timer block, going backwards, goes through low pressure switch, high pressure switch, and it turns into a purple wire going to our contactor. So right here I have the purple wire pulled off of the contactor and the blue wire that's going into the timer block right there. If my low pressure and my high pressure switch are both closed, I should have continuity, right? I'm going to try to do this one-handed. Hold on a second. Let's see if I can do this. Alright, that was kind of hard. But yeah, as you can tell, we're toning out. Do have continuity. My pressure switches are closed. Let's keep moving on. So, guys and gals, here's what we got going on. On terminal number 2 and 3, blue and red, I did verify that I have 208 volts, which is essentially the load side of the timer block, what actually energizes the timer to move. I don't know exactly what time it's set for, but I assume that 1 and 2 should be closed by now. So we're gonna just do a quick check of that. Alright, so I have no continuity through 1 and 2, so that's not closed. But what I can do, so I know this has power. And also, another thing I wanted to point out too, so you guys heard me reference a communicating line before. This unit doesn't use a communicating line. I busted out the manual. I read the fantastic manual. And the sequence of operations states that once the refrigerant pressure inside the unit is high enough to satisfy the low pressure switch, right there, it will then allow this blue wire to engage, thus initiating the timer, thus closing terminals 1 to 2, and then energizing our contactor. Now, based on the condition of this contactor, I believe that timer was probably failing and just causing it to just rapid fire, just cycle on and off non-stop, you know. I mean, it does work. The contactor seems to be okay. I have compressor action. Let's get a quick compressor amp draw if I can. 8.7. I'm like, is that even the compressor? No, dummy. Ouch. And then we went off on something. What did we go off on? I bet we're off on high pressure. All right, so apparently we lost power on our blue wire. Not real sure why. The head of the machine downstairs could have shut off on some sort of safety, so I'm gonna have to go check that first. But let's see if I can do this one. Right there, right there. Yeah, we got no voltages. Let's pull this off. Our system is off on low pressure high pressure right now, and I'm pretty sure we're off on high pressure because I didn't hear the fan come on when I had the compressor running, right? And I verified between purple and blue, like I showed you originally, was closed, is now open. So I just want to verify that I do indeed have voltage going through this contactor on the one side. This is just a single pole contactor. All right, so I have zero potential difference between top and bottom of this contactor. That means I do have voltage up top. Now, just to be sure, I'm going to go from the bottom of the side of the contactor that opens and closes to the right side of the contactor that's just got the bar across it, if you will. So I have 210 volts. So that means when this contactor closes, I should have 210 volts across the top two, which again, this is going to be hard to do, if not impossible, but I know we did because the compressor ran, so I don't even need to redo that experiment. But I don't know if I assume we had power at our fan wire. This is our secondary fan wire. This white one right here, that's one leg of the fan, which is right here. This is this white wire, and it ties into this point right here, which is on our contactor that goes directly into our fan motor, right? And then this other wire right here, black, is one side of our fan cycle control, which is right here. Now, I haven't popped the top yet and actually checked across this switch to see if our fan cycle control is open or closed, but what I can do real quick, and be very cautious if you guys do this, because I am working with live power right now. Just a simple, quick workaround. I can just plug this into the bottom, see what I'm doing here. I got no fan, no nothing. So I suspect our fan pressure control switch has failed. So let's pop the top and get at it. All right, here's our fan cycle control right here. Two black wires go into here, come down through here, and here's what I noticed. I don't think that's making contact, if any contact at all. It looks like it might even be burned a little bit from the lack of contact through there. Yeah, look at that. It's just barely hanging onto that. Although it was touching, though. I will give it that. It was touching. So, all right, I'm going to check across our control right there and see what's up with that. Meter. Dun, dun, dun. Right in the water. That's awesome. I love how meter leads just look at this. I've done nothing with these meter leads. I just set them down and they just randomly tie themselves. It's the most frustrating thing ever, especially when you're trying to do stuff like one-handed. Like, look at that. I couldn't do that if I tried. I don't know how that happened. That's one of nature's greatest mysteries. You know, like, I don't even get it. Like, how does this nonsense right here? Seriously. There we go. All right. Let's see if we can get these to tone out. So what we're gonna do, if I can, which I can't do it with one-handed, so I'm gonna set the phone down, guys, and I'm just gonna test across these two black wires going into my high pressure switch, see if we're closed. I'm connected across my fan cycle control, my pressure switch, and I got nothing. It's not toning out, nothing. Just to show you guys, see, I should have toned out, but I didn't. So my pressure switch is not closing. So the next thing I need to do is I need to get a gauge on there just to make sure that I actually do have pressure. I assume I do, since I have pressure downstairs at the head of the machine. But you never know on these wacky sorts of installs. Set that over there for now. Yeah, like I said, let me go grab my gauges and we will connect to that to verify that I have enough pressure to close that pressure switch before I go any further. And then, depending on how that goes, what I'll do is I'll just rewire this and run power directly to my condensing fan, just to verify that the fan motor itself works. All I got to do is take this one side of the wire and I can just connect that directly to my condensing fan motor right there, which I can probably do right now, just to be sure. All I'm going to do is bypass my switch. Let's see, make sure no dangling wires, nothing crazy. Alright, so my condensing fan is mechanically capable of running. It's just not getting the juice it needs. So we have a contactor that's mostly burned up because I believe the timer was failing in a way that was causing that to short cycle rapidly, and we may or may not have a bad pressure switch. So I got my gauges hooked up right here. Obviously this is our fan cycle control. I just have the high side hooked up. R404, we're sitting at about, I don't know, just a little over 200 pounds, which is about 90-ish degrees, which is basically what it is outside. The ambient temperature matches up. So I do have plenty of pressure, or the proper amount of pressure. It's not exceeding the pressure control whatsoever, so it should be closed, and it is not. So I will deem that fan cycle control as faulty. We already know the fan is mechanically capable of working, so we're going to need a fan cycle control, a timer, and then we're also going to replace that contactor. Or rather, I don't know if we will, because this particular situation is a little bit strange, as I'm being called in to look at something somebody else installed. So I'm going to quote it, but I'm not sure if they'll have me do it or if they'll just call back the company that originally installed it, because, you know, that's what they do sometimes. So that's where we're at, guys. That's my story, guys. I'm sticking to it. Be safe out there. Enjoy the weather while we got it, all right? We'll see you guys on the next one.